Okay, question 13, the last question of the practice test. Here we have a circle centered around 0, 0. The equation of that circle is x squared plus y squared equals 261. And we've got a tangent to that circle down here at point A, where point A is p, comma, minus 15, and p is positive. That's the only thing we know about it. And we're being asked about what the equation of the tangent at A is. Okay, what would be particularly useful first up is to work out what this value of p is. Now, A is a point on the circle, and so the coordinates of A will satisfy this equation of the circle. Okay, so what we know then is that A is at p, comma, minus 15, and A is on the circle, so we know that the x coordinate of A squared plus the y coordinate of A squared will equal 261. So we can substitute in p and minus 15 into here, and ultimately that should help. So x coordinate of A is p, y coordinate of A is negative 15, negative 15 squared is 225. Subtract 225 from both sides, and you get 36. Square root to get p, so at this stage then square root to get plus or minus 36, which plus or minus root 36, so plus or minus 6. But up here, of course, we're told that p is positive, so with that in mind, p must be 6. Okay, so that's useful. So we now know that that is 6 minus 15. Put that in red there. What next? So we've got a straight line. So a straight line has the form y equals mx plus c. We've got a point on that line, so we've got an x and a y coordinate. What we really need is a gradient. But there's a circle theorem from GCSE, which you ought to know, which is that the gradient of a tangent is perpendicular to the gradient of the radius meeting that tangent there. So if I just put in that dotted line there we go. And the gradient of the, so I'll just write that down, that's the key thing. So gradient of tangent is perpendicular to the gradient of the radius. So what's the gradient of this radius? Well, from 0, 0, we've gone to 6 minus 15. Okay, so the gradient of the radius then is, however you look at it, change, some sort of change in y direction divided by change in x. You may know a formula already for this, but you should at least know that fact. So what's the change in the y direction? Well, we've gone from 0 to negative 15. So we've gone down 15, minus 15. What's the change in the x direction? We've gone from 0 up to positive 6. So that's positive 6. Okay, so the gradient of the radius then is minus 15 over 6. If we simplify that, basically cancels through, come back to 3 there, so 5 over 2. So we've got a radius then of minus 5 over 2. Now, our tangent gradient is perpendicular to that, and perpendicular gradients are related in a way of being minus 1 over the original gradient. So that tells me that mt, which I'm going to use as the meaning of gradient of the tangent, is minus 1 over mr, gradient of the radius. Okay, and that's because they're perpendicular. Okay, so we've got minus 1 over negative 5 over 2. Okay, well, if you divide by a fraction, you flip and multiply. So flip it to become negative 2/5. Minus 1 times negative 2/5 is positive 2/5. Okay. So for the tangent, we now know that the gradient is 2/5, and we also know that the point A at 6, minus 15 lies on the line. Now that gives us an x and a y coordinate, which happen at the same time. It's a straight line, so it satisfies y equals mx plus c. It's of the form y equals mx plus c. Gradient is 2/5, so that can go straight in. Now we've got this particular point 6 minus 15. So when x is 6, y is minus 15. Substitute the 6 and the minus 15 in there, and the only thing left to find out is the c. Okay, so 2/5 of 6, so that's 12, 2 6 is 12 over 5. Subtract the 12 over 5 from both sides. And if you do that on your calculator, that's a minus 2.4, so overall then you get minus 17.4. See? Okay, and incidentally, 2/5 there can be written as 0.4 as well. So we don't like to mix fractions and decimals in the same expression in general as mathematicians. So since I've got c as minus 17.4 and 2/5 is exactly 0.4, we might as well then write it as y equals 0.4x minus 17.4.